Okay, to solve this first example, first thing I want to do is look at the equation. I see that I have a y squared as my highest y term and an x as my highest x term. This means I am dealing with a parabola and that it's going to be a sideways parabola, either opening to the right or to the left. If I solve using version 1 of our equation, I start by solving for x, so I get 2x equals y squared minus 2y minus 5. And now I get x equals 1/2 y squared minus y minus 5 halves. To solve for the vertex, I solve for the y coordinate first because that's what's squared, where y is going to be negative b over 2a, which is negative 1 over 2 times 1/2, and that reduces to 1. To solve for the x coordinate, I plug this 1 into my equation, which gives me negative 3. Thus my vertex is at negative 3, 1. So I come over to my graph, and I get a vertex at negative 3, 1. Furthermore, I can look back up at my equation here. Because my y squared term is positive, it means I'm going to open right. So I know that this vertex is going to open this way, or this parabola will open to the right. But just to be a little bit more precise, I'm going to go ahead and plug in another value for y so we can plot another point. Let's say that y is 0. This means that x is 1/2 times 0 squared minus 0 minus 5 halves, which gives me x equals a negative 5 halves, or negative 2.5. So I get the point negative 2.5, 0. Come back over to my graph. I get negative 2.5, 0. And then I have its reflection up here, because I do have a line of symmetry through the vertex. So I also have the point negative 2.5, 2. And that gives me the graph of my parabola. There is a second way to solve for this graph, and I want to look at that one as well. The second method is version 2 of the equations we saw above, and it involves completing the square. So what I would do is, again, get your x on one side and get y squared and y on the other. I'd go ahead and leave that coefficient in front of x for now, because what we're really concerned about is this y squared and this y term. To complete the square, I take y, and then I notice this is going to be my middle, the negative 2y is my middle term. So what I need to do is take this negative 2, divide by 2, that gives me a negative 1, and then square it. So I get which would give me a positive 1. For right now though, you just take the negative 2 and divide by 2. So that gives us a negative 1. If we were to actually multiply out y minus 1 squared, we would get y squared minus 2y plus 1. So to account for this 1 that we've added in, we need to subtract 1 from the end. That way the 1's would effectively cancel each other, and it's not as though we're adding any numbers without keeping the equation balanced. Alright, finally I get 2x equals y minus 1 squared minus 6, which means x equals 1/2 y minus 1 squared minus 6. I look at these two numbers for my vertex, or no, not minus 6, but minus 3. Don't forget to divide by that too. So I look at those two numbers for my vertex. I realize my vertex is at negative 3, positive 1. You only change the sign on the number inside the parentheses. So I get negative 3, positive 1, and you can use the same method of just plugging in 0 for y to solve for the other points on the parabola.